Okay, so now we saw how we do Fdisk here. Okay, and we went through all this here and choose the file system used here. So what we did is we used file system ext4. So what I'm going to do is I'm going to choose another hard drive here and make use instead of ext4 I'm going to use Xfs. Oh, before that, all right, let me log into my system here. Okay, so what we have here is we made the CD and we attach the I'm sorry, not CD, the first hard drive we have, right? Let's take a look at the diagram here. First hard drive SDB, which is 8 gigabytes. We used that and we formatted and we did whatever we need to do, and we attached the hard drive here to the folder called data/Chicago. Okay, and if I go into that folder, I'm gonna say ls-l. Last time we had
Can you hear us? You're still muted.
oh, sorry, can you guys hear me?
Yes, now we can hear you.
Oh, okay. I was talking on mute. All right, sorry about that. All right, so what I was saying was, last week what we did was we gave our attention to one hard drive here, okay, SDB. Okay, and we followed the fdisk commands, and this is the process of following the fdisk command here. So we made the hard drive ready so that we could use it. Okay, and when we did fdisk-l, this is the information that will come up. Okay, we have written this and disk is not usable yet. Okay, so what we did was we did fdisk-l and this is the output that came out. fdisk-l/dev/sdb1. Oh, okay, I have to be root. So what I'm going to do is I want to find out some information about this drive here, SDB1, right? So you do fdisk -L as in Larry and hit enter. And you will get this information, output information. Let's do SDB. Okay, yeah. I like this command. So when you do just SDB, it will give you this output and you have information here. What you're really looking for is you want to see how many partitions you have on this drive. Okay, dev/sdb1 and dev/ if it's going to be 2 partition, it will have like a next number in it, SDB2. Okay. All right. So what we did was we used mkfs ext4 file system. And so just remember with this file system, ext4, the maximum disk size could be 1 exabyte and the maximum size of a single file is going to be 16 terabytes. And the Xfs file system maximum is going to be 16 EB byte, and the maximum size of a single file is going to be 500 terabyte, and then for Red Hat 8 is going to be 100 terabyte. Okay, wait a minute here. Why is Red Hat 8 low? Why is Red Hat 8 low? Give me one moment here. All right, so let's see here. Okay, it says 100 TB byte. Red Hat 8. ext4 16. Let's see, Red Hat 7. Okay, actually it's 8 EB byte. Individual file size, right? (500 TB byte) and 8 EB byte. But I don't understand why is it saying 8 EB byte in the brackets. Alright, for now I'm gonna put 8 EB bytes here. Alright, so in reality I'm not sure if any file is going to be that big. I never really saw anything more, in terabytes either. The maximum I ever saw is something getting into like 100 gigabyte or something. Nothing more than that. It's kind of risky to do all those things there, so I'm not worried about that. Now, what I'm going to do is I'm going to unmount the hard drive. Okay? So, if I do df-h, df-h, and I see this hard drive, SDB1, which is about 8 gigabytes, and it's being used on this folder here. Okay? So, if you have a folder, you want to see where that folder is sitting, being used, what you have to do is go into the folder cd data Chicago and do df-h and a period. What is a period means? Anybody?
Present working directory.
Present.
Very good. Present working directory. So when you hit df-h present working directory, it will tell you this specific entire directory, not the data. Okay, you got to be careful with this. Right now the data directory is independent of this directory here, /data/Chicago. Okay, so /data/Chicago, you will get an answer here. It is being used over here. Okay, let's look at what is data doing. /data, and if I do df-h and a period, now what you see, /data is being used by /data is using which hard drive? You get a information here. It's using the root hard drive. So if you save any data on /data, it's going to save here. Okay, and if you use save data on /data/Chicago, is going to save data over here. Okay, so now let's unmount this. I'm going to say umount /data/Chicago. Okay, and I'll hit enter. And if I do df-h, /data is not being used anymore, and you know how the SDB1 is not in the picture anymore because it's not mounted, it's not being used by anything. If I do, now if I go to cd/data, can you go on mute please? Everybody go on mute. Okay, good. Now the directory is still there, cd/data/Chicago, and if I hit enter, if I do df-h, what I'm supposed to see here? Anybody?
The root?
You were root. Very good. Very good. What happened here is we removed the hard drive which is underneath there. Okay, the root hard drive was underneath the folder /data/Chicago. Since we unmounted it, since we removed it, what happened was so this one here /data/Chicago, think it as it like a bucket, right? A bucket was holding it, and this is a /dev/SDA SDB1. Okay. All right. So now where did the files go? Where are the files sitting then? Now this is back to root. Now this is in a back to root bucket right here. This one. So /data/Chicago is in root bucket here. Let me just remove this.
So what you're saying is, once you unmounted it, you could say it fell out of the SDB1 bucket
Yeah,
back down into the root bucket.
correct. That's the best way to describe it. Very good.
Okay.
All right. Now the system. So now where is the data SDB1? If I do ls here, I'm going to find the data here or not? Okay, let's take a look. All right. So if I do ls hyphen L here, that there is no data. Data is gone. Why data is gone? Because data is sitting on this drive here. Not here. I mean, you can see it. This drive, the only way you could see is lsblk, list block, and you see here SDB1 is sitting there and getting wasted. It's not being used. If you don't see anything around this area, it's not being used. Okay, if you see anything, if you right here you see this here, this is being used, this is being used. Okay, and you have something here, this is being used, and our SDB1 is not being used. Now I have an option here. I don't have to use the same folder. Let's try to put this on a brand new folder called data slash we'll do Oracle. Okay, So I'm going to create a brand new folder, mkdir slash data slash oracle. Okay, make sure you add -p. Now I'm going to do is mount. You have to give the name here. So how did we mount here last time? Mount dev sdb1 to /Chicago, right? So what we're going to do is we're going to type the same command but change it to /oracle. Dev sdb1 and /data/oracle, and I'll hit enter.
Mr. Zafar,
Yeah,
what does the -p do when you do
it
make directory?
it preserve the directory. So what -p does is, if you could have like a lot of directories in there. So when you're doing a -p, and what it does is it detects data is already there, right? So it moves on to create oracle.
Okay,
Okay.
so if you did it, would it just override it or just create another?
No, it preserves it because there may be some data sitting in there, right? P stands
Yeah.
for
No,
preserve.
if it didn't use -p, what would happen?
If you don't use a -p, then it may create a problem here. It's a fail-safe to
Okay.
do -p. If you're creating a folder within a folder, then make sure you do a -p.
Okay.
What might happen is the data folder will still be there, but the permission might got changed. Okay. Preserve directory. All right, that's an assignment for you. So find that out and let me know next week that what will happen if you don't do -p. Okay.
Okay.
All right. Now, if I go in there and if I do ls-l, see the data is present here. Earlier it was in data / Chicago. Now it's sitting in data / Oracle here. So it's just think the folder as it's just a window into the files, just a window into the data, into the hard drive you're working with. Okay, so this is insignificant. You could keep the data here and then mount it anywhere you want. This is specifically called mount point. This is the hard drive and this is the mount point. Okay, so you call it as a mount point. And what is the file system? This is the file system and this is the mount point. So it could be anything. All right, let me go up. Okay, so this is the dffnh and a period. It will tell you which directory is being used for file system here. Okay, so that is that. Let me get rid of this. And here's the command you need. Let me highlight that. Okay, and so, and yeah, this is good information. You need to know that too. 1 point directory is independent of 1 point directory is independent of other directories in. Okay, so by the way, you have to use absolute path when you're mounting it. Okay, that's given here. There is no way it's gonna work without a. So I'm gonna make a note here. Absolute path. So I'm gonna put a today's date here. Okay. Now over here we unmounted and unmount the disk. All right, be very careful in the real world environment what you unmounting and not mounting. Okay, you don't want application crashing. More than likely the file system you're working with, the database. Okay, those are very very important, and make sure you're careful with this. I mean, the thing is, the more you practice here, the better it gets. Okay, now what I'm gonna do is okay, and so this one is just showing here /Chicago. after unmounting directory is using root VG, root volume group. Okay, that is coming up soon. All right, so we'll leave that part alone. And you did ls here, nothing is there. And here so at this point it's not being used. Okay, so this is just sitting there and getting wasted. And okay, now mount /dev sdb1 to completely different directory. Okay, so now what I'm going to do is I did this here. I created a directory. And then I mounted it and I did df-h. So the directory is back. I'm sorry, the SDB1 is back, but it's sitting on a different directory now. Okay. And again, this is mount. This is the source and a destination. This is going to be your formula here. File system is source. Okay, and this is absolute path is a destination. Okay. Any questions so far? I'm going really slow here, so you should just follow along. And we mounted it here, right? We mounted it here. Source and destination and absolute path. We mounted here. So what happened? Now, when you go in here, the data that was in the other directory, it's showing up in here, okay? So that's how you attach an extra hard drive. And now, in reality, you should be able to take this hard drive and put it into the another system and it should work just fine. The data should be there. So if the system goes down, this part of the system goes down usually. Okay, because why does that part of the system goes down? Anybody? If the system goes down really bad, really hard. Okay, so why this part goes down is this part is holding operating system. It's holding operating system, that's why if the system ever goes down, it will take that part with it, or it got corrupted or whatever happens. And then the data part on this part, it could be preserved. You will literally take these drives and plug in into another system. It will work just fine, as long as they are using the same file system or whatnot. Okay, all right. So let's mess around a little bit more here. Now, what happens? What will happen if I restart the system here? Let me get out of here and I'm going to restart the system, okay? Anybody knows the command to, I think I never showed you guys the command to restart. To restart the system, it's init6, init6, and hit enter. Actually, you could type reboot also. All right, it should be back by now, or maybe not. Yeah, it's not back up yet. Okay, so I have like bunch of systems here sitting in here, and probably need to be successful. So practice this as much as you want, because but just imagine you're playing around with like Oracle database, IBM DB2 database, and all that. So there should be not margin for error when you're working on this. And then it gets easier. The more you do it, the better it gets. All right, now let's play around a little bit with Xfs file system here. So what I'm going to do is Xfs file system. Xfs I'll guarantee more than likely you will never work with ext4, but I'm putting this over here anyway. Over here, I'm gonna say ext4 file system. All right, is that good enough, Shakil, or you need more explanation? Let me know.
No, and it does it matter which order you go? You mount first, then
No.
the VI file, or
It doesn't matter.
okay, thanks.
But to do the test, go into FS tab. That way, if you do it, you know for sure it's going to reload. If it's going to be any error message, you will know right away. Okay, good. Now let's work with Xfs File System. So over here, what we're going to do is, let me clear. And let's see here. We have SDC here sitting there and getting wasted. So what we're going to do is, we're going to create a file system on this using Fdisk. Okay, so I'm going to say all right, I'm just putting here for the visibility here. So I'm going to highlight all this and create Xfs file system using Fdisk method. Okay, let's run through Fdisk command here. I'm not going to go through that again. So what you're going to do is, I'm just going to go through. I'm not going to document that, because what I'll do is I'll make a different. Okay, by the way, I made this split the document up so that you could easily access this. Okay, and everything down here, over here is the main document, which is running, which has everything from day one. All right, so what I'm gonna do now is let's do Fdisk. So you do Fdisk, and what is the address? What is the full absolute path for SDC? /dev/SDC. Okay. Okay. Now we got our command there, M. I'll hit enter, and then what I need to do is I need to create a file system here, right? So which option should I do? Print partition information. Okay, it's a good habit to do print partition information. P and hit enter. Okay, so what you see is down below here, you don't see anything. That means partition is not there. So let's do toggle print create okay, N, add a new partition. Okay, N, hit enter. So I have everything documented here, right? If you go into, right now it's not split up. I'll split this up later. So you will have a menu over here on the left side, Fdisk commands and all that. Okay, blindly follow this. Most of the time, this is what you're going to be using it. N, and then hit enter, 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 and it will take up the maximum size. Okay, so I'm going to hit enter, primary partition, yes. And then the partition number default is 1. And the size, I don't care, the default is 2048. And it says last sector, the size you're going to use is default, the entire disk. Okay, and if I do P and hit enter, now the partition is here. If you looked earlier, you hit P and hit enter, this information is blank. But over here, we have information here. Okay, and what you need to do is to save and exit the Fdisk, what you need to do is write W and hit enter. So W and hit enter. It writes the file system and it's ready here. It says here partition table has been altered, and then it's there. Now if you do LSBLK, you have the SDC there. But if you do BLKID, the file system is not on it yet. So you have SDB1 file system. This is ext4. Okay, it will start showing up here once we run the file system. Now, the command to create the Xfs file system is simple. mkfs.xfs and the location of the hard drive, dev/sdc1, and hit enter. And it ran through whatever I need to do, and the file system is ready. So if I do blkid, you should see the new file system down on the bottom here, SDC, and the UUID, the block size, and now this is a XFS file system compared to the one we have. It was ext4. All right, guys, I'm gonna pause here. Let's take a good 20-minute break, and we'll be back at noon Chicago time. All right, break starts now. Okay, I'll get started. Can you guys hear me?
Yes, we can hear you.
Okay, thank you. All right, so let me make sure the recording is on. Okay, so we made the XFS file system here, right? So what we're gonna do is, so everything else we're gonna follow the same. Okay, so let's see what we got here. Before that, in SDC1, and this is the file system we just made. And this is the command to make Xfs file system. Okay. Now, what I'm gonna do is I'm gonna I'll see dffnh, not dffnh, lsblk. Okay. Now you see SDC is there, but SDC is not mounted here, not being used. So what I'm gonna do is I'm gonna mount it to the Chicago. Okay. So how are you gonna do that? I'm gonna do vi etc fs tab, and what I'm gonna do is I'm gonna copy this file here, yy and p. Okay, if you go into the vi editor, I put it in there how these things work, copy, paste, and all that in the vi editor. And what I'm doing is I'm just changing simple things around. I'm making corrections here. So dev/sdc1 and is going to go on to Chicago. Okay, and the file system is going to be Xfs now. We'll leave everything else the same. Xfs. All right. Escape, shift, and exit. And what I'm going to do is I'm going to do df-h. It's not there, right? Oracle is there, but Chicago is not there. So what I'm going to do is mount -a and hit enter. I didn't get any error message. That means it's worked. And there you go. I have two file systems here which are separate, and then it's using two different hard drives here. One is 4 gigabyte, another one is 7.9 GB. Any questions? Okay, so let me put this. All right, so we made this entry here, copied the line, and we edited as needed.
Mr. Zafar,
Yeah.
in the etcfs tab, if you add where you added data/Chicago, if you added a directory that wasn't there, would it just hit you with the error?
Yeah, definitely.
Okay.
You gotta be careful. Don't put root in there. It's gonna create a lot of problems. The ones here, unless you're getting ready to quit the job, you could mess things around. Yeah. So if you do something like this one is already there, so it might, do that. But if you have like a cd home, and if you do ls here, you see all these other users here. Those other users will start to have problem getting into the system. And usually one of the user will be like a database, and they will have also starting to have problems. So yeah, I mean,
That's only if you change the root to a different mount point.
No, not root. I mean, these are established file system, right? /home has users folders in there, right? So what you do is if you just mount it /home, then all the folders will be gone from there because it's not, those folders are going to be in the different directory. These folders going to be sitting in here if you attach attach another hard drive in here. Did you get it? The same thing what we did early on, the start of the class today.
Yes, I get it.
Yeah, okay.
Because all the data is in a different disk.
Yeah, data is not there. All right, now let's see here. We did all this and it's not there. Okay, and let me put this in here. We did mount -H. Mount -A, what this one does is load what did I type earlier? And there you go. This is where your newly minted file system is. All right, so now we learned two different ways. One is ext4, another one is XFS. Okay? For us, it's meaningless. It's just visual. You know, for us, it's just like the text ext4, XFS. But for the computer file system, it means a lot. So more than likely, you would end up only working with XFS file system. ext, some places they have. The place I'm working right now, they're using ext. All right, so moving along, let's get into LVM, Logical Volume Manager. Okay, so this is really important. What we're gonna do is I did Fdisk. Let me do. All right, so now what we're gonna do is LVM Logical Volume Manager. All right, so what we're gonna do is more than likely you would never end up working with Fdisk, okay? So the only thing you will be most likely working with is LVM. But for your knowledge, you have Fdisk here. So everything that you need to know about Fdisk is here. So let's move on with the logical volume manager. What we're gonna do is, okay, so all right, so let's look at our file system here. Let me, so you know how we have here one, the first one is a root, the second one is you know, everything else is free up now, so we end up using the second one and the third one. What we have left now is 4, 5, 6, 7, 8. Okay, so to find out what drives are not being used, what you do is lsblk, that's your boss. All right, you run this command and you say, oh, okay, I have SD, SDD, SDE, I have 16 GB, 16 GB, and SDF, 6, 12, and 24. I have all these on purpose here, different sizes. So what we're gonna do is we will work on what we'll do is we'll combine, let's see, S, D, E, F, and G. Okay, we'll combine this 3 hard drives into single hard drive, okay? So combine 3 hard drives into single drive. What I should do is okay, so what we need to do is we don't need to worry about Fdisk. So what we're gonna do is we just start running the commands. So LVM commands, the very first command we're gonna do is, once you identify which disk you're gonna be using, you have to, okay, by the way, you just see SDE, right? But what is the directory location for SDE? Anybody? What is the absolute path for SDE, I should say?
etc.
No. The full path of SDE. All right, let's go back here.
Dev slash.
Yeah, very good. /SDE or SDF, whatever we're working on. So this one is going to be, so the command is pv create dev/SDE and dev/SDF dev/SDG. Okay, so let's see how this is working. So what we have here is we determined SDE So we have SDE. Oh, it can't. It's not working. Okay, so we're gonna use SDE, SDF, and SDG. Okay, and when we do that, SDE is how much we have 16 GB. SDF is 6 GB. Okay, and this is 12 GB, right? SDG is 12 GB. So what will happen is going to be a combined. So this is going to be, once the disk is ready, all three disks are combined, is going to be a total of 34 GB. Right? It's going to be 34 GB. And what is this going to do is PV create is, there are two in there. PV stands for physical volume, and create means create. So this command, what it's going to do is it's preparing the physical volumes to be as a part of LVM. Okay, that's all there to it. All right. So I'm going to hit enter. I'm going to hit enter. You get the message that says pv create / dev whatever that is created now. So I'm going to copy this. Combine the drives, and this is going to be 34 GB. Okay, and let me copy the screenshot. Okay, now you get a message here that physical volume / dev SD is created and all that. You get that message here. If you do ls blk, all right, so we don't have much information here. It's the same old information. So the next thing we're gonna do is we're gonna make it PV create, right? So what we're gonna do is we're gonna combine all of them and find out the total volume is going to be together. But before that, run this command here, PVS. PVS stands for physical volume show. So what is happening here is it's showing physical volume, which is going to only show you the LVM. It's not going to show you the one which is not LVM here. So these two are not LVM, so it's not giving you that information. Since the original root /SDA2, which one is that? /SDA2 /dev/SDA2. These two are using logical volume, LVM. Okay, so that information is showing up here. And if it's going to be a physical hard drive, it's going to be the same exact commands, no difference. Okay, and PVS, what is stands for is physical volume show. So what it does is shows the LVM shows the disk which are of LVM. All right. Now what we did is we created 4 volumes here, right? And earlier I said we're going to put all this together as a one group. Okay, so what we're going to do is we're going to do volume group. So what we're going to do is the command is VG. Let me turn this off. Q&A. Did somebody ask a question? Oh, on here. Okay. Earlier. Close caption. Turn it off. Okay. Now what we're gonna do is we're gonna. Oh, come on. So this command will put all these 3 drives, we are putting it together into a single drive. So what we're going to do is VG create and the group name we're going to have to give. The group name I'm going to give is ZMPT01 and the devices. So I'm going to say SD dev/SDE, SDF, and SDG. So what is happening here? So this is the command VG this command stands for volume group create. It's not working good. VG stands for volume group. And we are giving the volume group name. Name of VG. And the devices that need to be in there. I should say disks part of volume group. All right. Does it make sense? Let me save this. I'm going to say does it make sense so far?
Yes.
Yes.
Okay, good. So now we don't have to worry about SDF and all that here. So we just worried about ZMPT1 because that is the main volume group. Okay, now what I'm going to do is I'm going to make sure the volume group is working here. So what you could do is you could run the command VGS. The earlier command we ran was PVS, physical volume show. Now I'm going to say VGS, volume group show. Okay, now it's showing RHEL1, which is this one here. This is which one is this one here. RHEL1 is using SDA, and it has a one partition in there. So it says, if you look under physical volume, it says 1, and logical volume. I'm sorry, this is physical volume also, and it makes sense, right? ZMPT1 has 3. How is it 3? 1, 2, 3. 3. And logical volume, logical means imaginary. It has 2 on here, and ours doesn't have anything. Well, how this is 2? I'll show you. This is 1 and this is 2. Okay? So now this is a good command you should run all the time. And also
So
it will show you, I'm sorry, go ahead.
So is the LV the partitions?
LV are the partitions, correct.
Okay.
So we don't have any yet. So it's giving you the current information right now. So it has 3 physical drives and no logical drives. And how much is free? 34 GB is free. 34 GB is the total size, and 34 GB is free. displays volume group, PV physical volume, LV logical volume, and volume size, and volume free. Alright, this is a very good command. I use this all the time. It says VGS volume group show. It will show you the information here. And let me highlight this here, PVS, PV create. All right, so what I'll do is I'll actually do a little diagram. So we have first hard drive slash S dev slash SD E dev slash SDF dev slash SDG. Okay, and and what we're gonna do is let's put down the size. How much is the size? Let's go up. So 16, 6, and 12. 16 GB, 6 GB, and 12 GB. Okay, now what we did was we combined all this, we combined 3 individual drives here. These are 3 individual drives with different specs and all that. We took all this here and we combined this into one single drive here. And we gave it a name. What is the combined name for all this? Volume group? Volume group is ZMPT01. And how much is this? This is 34 GB. All right, so ZMPT is 34 GB now. Now moving along, now treat this as a single disk now. Okay, so what we need to do is, now we have a requirement. So I already have this information, and let me just copy and paste it here. So we have 3 different departments here, right? Accounting, finance, human resource, and database. All these different groups, you're using this server. Okay, they need to keep the data there, and they need a space. So this is the requirements here. So what we're gonna do is we're gonna create one at a time here. So now this thing is a one big chunk here. Out of that we need 4, right? 1, 2, 3, 4 partitions. So let me split this up. And so the first one is gonna be accounting. Alright, second one is gonna be finance. Third will be human resource. And fourth will be database. And how much accounting needs is they need 4 GB. And finance need they need 6 GB. And HR needs only 2 GB. And database they need okay, obviously if you come across database sizes being normally the data size is usually terabytes. 500 gigabyte, 1 terabyte, 2 terabyte, that's the normal size of database. So how much we have here? Okay, what is the total here? This is 10 GB. Let me split this.
22.
22 is used up, right? And the rest is free. So this is so free space is 12 GB, right? Out of 34, 12 GB. Alright, so now let's create accounting. Very first one is accounting here. So the command we're gonna have to create for accounting is let me clear the screen, come down a little bit. The command is lv create. So LV stands for logical volume create, and -n means new. You're telling the system this is a new command, and you're giving the name accounting. Okay, and -L as in Larry, capital Larry. That means this is a logical partition. And what is the size? What is the size requirement we have is 4 gigabytes. 4 GB. So you don't have to give B, all you have to do is 4G. Make sure you do the uppercase G or else it won't take it. And where is this coming out of? Where are we carving this logical volume out of? We're cutting this out of
ZMPT 01.
Yeah, very good. ZMPT 0. ZMPT 01. This is logical volume create. Okay. And this part -n means new. And this part, name of a logical volume. So you should put this as compatible with the department or whoever they're requesting, okay? And you should give it a name new. Name of logical volume. Okay, and -l means make it a logical volume or make a logical partition. Partition.
So what does that mean, Mr. Zafar? By making it a logical partition.
Yeah, even though you have the command here lv create, you still need to know logical means it is not a physical partition. The fdisk partition we did, it was kind of a physical partition. Even though it's on the disk, it's like making the boundaries here. So logical, when it makes a logical partition, that partition is flexible. Actually, you could extend that logical partition anytime you want. Okay, and this is the size and the volume group.
Okay, so you mean like and how you do it with Fdisk, you can't change the size of the partition?
Exactly, you got it, man.
Okay.
Fdisk partition is kind of stuck.
Yeah.
You could extend the Xdisk partition forward. You cannot go backward, and you cannot change it in the middle. I'll show you
That's
how.
for
Wherever
logical, this one?
no, that's for Fdisk. For logical,
Fdisk.
it's very flexible. You could change it, the middle partition, the end partition, the start partition, no matter what.
Okay.
Okay. I'm gonna hit enter, and it says logical volume accounting created. Now the command is lvs logical volume show. Okay, now it's showing. Okay, you see root and swap, they are sitting on RHEL volume group. So let's go up and verify that. All right, in a minute I will do that, okay, because you have to do DFF and H. And this is the one we just created, accounting, and it's sitting on ZMPT1. Okay, so now if you do df-h, no, not df-h, let's do lsblk. Now, if you do LVS, LVS stands for logical volume show. And you see root here, root here. It gives you like a logical name and then hyphen root. That's how it goes. Okay, and swap, swap, and then the name. Okay, and now accounting, you see accounting here, and ZMPT 1, ZMPT 1. So now what will happen is all these three are part of the group here, and since this is only 4 gigabyte and the very first E is is big enough to support 4 gigabyte, is going to put that partition over here. Sometimes it's possible what it could do is it will put a partial over here and another partial here. It will manage all those things automatically on its own. We'll see when we move forward here. Okay, so what is happening here is with the commands we ran, first it created /dev/sde. It became a part of a volume LVM. Then we did a pv vg create. It became a part of a ZMPT01. Out of that we carve out accounting. So now it's showing 4 GB, and over here it says LVM. Okay, for the other ones it's not showing LVM. It's just saying part, means partition. This is LVM, logical volume manager. All right, so let's move on and create our other ones. Okay, using the same command. So I'm going to go up here. So this is the one that was created. So what I'll do is I usually bring the line back here, and the finance is what, 6 GB, and I keep everything same. And what I'm going to do is I'm going to do finance. I'll hit enter, and now I'm going to go HR is 2 GB. Human resource. I'll bring it back here, and database is what? 10 GB, right? Database. All right, I'll hit enter. So all these things were created here. So what I normally do is I create this, I save it myself here, and then I'll do LVS. LVS, logical volume show. There you go. You are concerned about this part here. So it's giving you a clear picture here. You have ZMPT, this is the base, and on ZMPT, database is sitting on it, accounting, finance, and HR. And this is a different volume group, and this is another different volume group. Okay, so now what we did was we combined 3 hard drives into a single hard drive, and then we are making partitions out of it. Now how are we going to use that? How are we going to use we made the partitions, right? How do we do that? All right, so VGS shows you the volume group, how much the size is and how much is free. Okay, now you still have to do, what is the next step here? Anybody can take a guess? I'm going to scroll so that you could get the idea. we have to do partition, either XFS or ext4. By the way, you could make one XFS, the other ext4. Actually, we're going to do that now. What we could do is almost all the time in a real world scenario, you just have to do XFS. You don't have to do ext4. Using Xfs file system. Okay, so the command is easy. What you have to do is you have to clear this, do lsblk, and you have to find this out. Okay, so what you need to do is the command mkfs.xfs and the full path. So what is the full path? /dev/zmpt. Okay, now you don't have to do dev/SDE and all that. It will be confusing, right? Even if you do it SDE and all that. Okay, now here you go. So SDE, SDF, and G are part of a same file system here, right? But since this is a bigger size, it put it on this one here, which is holding 12. And the other two ones are smaller size, so still continuing on to SDE. SDF is just sitting there. Okay, but it's still part of a volume group. So the command is mkfs.xfs dev/zmpt01, and I'm going to say accounting and hit enter. I'm going to bring my line back and I'm going to do finance, enter. I'm going to bring my line back and then I'm going to do HR, and I'm going to bring my line back and I'm going to do database. Okay, so let me copy all these. And you don't need all this. I'm going to wrap this up in another 5 minutes. Okay, this one here, database. Okay, so these are all the commands you just have to run. Okay, now what you have to do is you have to mount it. All right, so let's create a associated directory for them. I'm going to do mkdir/accounting. Okay, mkdir/finance, mkdir/HR, mkdir/database. All right, let me copy and throw that in there. create mount points. And now what we need to do is we need to mount it. Okay, so how are we going to mount? You're going to mount to get the mount point information, you do blkid, and it's kind of different here. The mount point information over here is you have to use this. But you know what? Hold on. Yeah. If you look at it here, this one has a mapper in the middle. So you have to follow the same rule. So what I'm going to do is I'm going to do dev mapper accounting. I'm going to copy all these here. Let's do accounting. Let's do database. So what I'm going to do is I'm going to do vi etc fs tab. I'll go down here and I open a new line. I'll paste this in there, okay? And what I'm going to do is /database, and then rest of the stuff I'm going to copy it from here. Copy paste. If you want, you could like bring it to the same line here. Escape. I'm going to copy this line 3 times. All I have to do is go back and change this part here. Database, then what I had is finance. Make sure the spelling should match. If the spelling is not matching, it won't work. And this one is HR.
Mr. Zafar,
Yeah.
what did you click or type to do the copy and paste like that?
Double Y.
Double Y. Okay.
When you're on the line, double Y, and then come down wherever you want, then do P. It will paste it the line below.
Okay.
So go into the VI editor here, and you have all the tricks here. Go into VI editor, and practice this really good. Not the right here, VI editor. And here's the cheat sheet here. Just follow that along.
Okay. Thank you.
Yeah. Okay, and accounting. All right. I save and exit. I do df-h. Nothing is there. I do mount-a. No errors. That means it's mounted. Beautiful. Look at that. Do you see this? Database, finance, human resource, and it's telling you 10 GB, and this is what is available. It's about 2%. In computer environment, everything, if you say like, if you buy like a cell phone, 64 GB, you're not going to get exact 64 GB of disk space available, because there's going to be some small database metadata written so that the operating system knows where things are. So you would lose a little bit of disk space. That is normal. All you're worried about is here. Okay? So next week, what we're going to do is we're going to create a script, and whatever the hard work we did, we're going to run that on two other systems, and it will be done in a fraction of a minute. It will be done like in 30 seconds. All the work you did so far. Okay, so I'm going to end the class and I'll upload it as soon as this is done. And I'll see you guys next week, and then I'll put up a assignment for LVM. Please do that. And the more you do the LVM, the better it gets.
Okay. Mr. Zafar, so this only was able to be viewed when you did df-h because of the